Okay, let's give you guys some more practice. So now we are back on Earth. Gravity on Earth is 9.8, but we're going to round off to 10 meters per second squared. We're going to fire a cannonball at 100 meters per second at an angle of 15 degrees. So when you fire your cannonball, it will look something like this. Um, Calculate the maximum height here. Okay, calculate this maximum height, and also calculate the range. The range is a distance given by this. Okay, so two questions. Calculate the maximum height and also calculate the range. Okay, this is all that you're given. So press pause and have a go. Okay, so your answer should look something like this. Um, First, break this up into your vertical component and your horizontal component. So then jump to your velocity time graph. Velocity time graph here. The equation for this line here is given by this. You're trying to find out the time it takes to get to the maximum height. Well, the time that it, well, the at maximum height, when you reach maximum height, the velocity will be zero because this here is T max. The velocity at T max will be zero. So you put zero into this V here, and then this equation here will now become this. Okay, because you're putting zero into the V here, and then work backwards to find out T, because that then would represent the time it takes to get to the maximum height. So it's blur, blur to get to the maximum height. So T here, T max is given by this. Okay, so now that you know T max here, so basically you know this length here. Remember, this length here represents time because going along this axis is time. Okay, the up and down here represents velocity. Well, anyway, now that you know this and you know this, this is our initial velocity here. So remember that the area underneath the velocity time graph represents a distance traveled. So the distance traveled vertically upwards would be given by the area underneath this graph here. So to find out the maximum height, get this height here, which is given by 100 sine 15. Okay, and then you times the across here, which is given by this, which is really T max. Okay, and then because it's a triangle, divided by 2. Okay, so at the moment you've got this times this, and then you've got to times it by this times this. So single number, 100 is also a single number, so we can merge these two together. Okay, and then you've got sine. Well, just remember that this here is just a number. Sine 15 is just a number, and here you've got another number that's exactly the same as this number. So merge these two together. So that's sine squared 15 over 2. Okay, and then now you can imagine this as being like this. So 1000 divided by 2 is 500 sine squared 15. So maximum height is given by this. Okay, so that's one question done. Now looking back at our velocity time graph, we've worked out that T max here, which is given by this length here, is 10 sine 15. If you don't believe me, you can scroll back here. T max is 10 sine 15. Okay, 10 sine 15. So looking back at this graph here, this length here is 10 sine 15. So well, when you fire the cannonball like this, well, if the time it takes to get to maximum height is whatever this number is, well, times it by 2, that will give you the total flight time. Okay. The weird thing is that the time it takes to travel from here to here is the same time as it takes from here to here. So times this by 2. Okay. So total flight time is 2 times this length here. Okay. Times that length there. So hang on. So now at the moment it's this you've got this times this. Remember that this is just a number. So let's merge these two together. So that's 20 sine 15. Okay, so the total flight time is given by this. So looking back here, the total flight time is 20 sine 15. Okay, we just worked that out here. The total flight time is this. But then you then have to imagine you and your dad sitting in a car driving horizontally across here at a speed of 100 cos 15, and you're doing it for this amount of seconds. So the distance is speed times time. So you basically get this times this. So range is given by this thing here, which is this, and then you times it by the time. The time is given by this. So range is the speed here times time. So at the moment, what you've got is this thing, this block times this block, and then you times this block, and then you times this block here. Let's merge these two together. That will give you this, and then because this number here is different from this, you can't merge the two. Okay, they're different. They're different, so you can't merge them together. Let's leave them as cos 15 and sine 15. So the overall range is given by this. Okay, and we can leave it as this. We don't always have to convert it to a decimal. You can if you want, but let's just leave it as this. Okay.